Marcus. So what we're going to do is we're going to have, I've got Nick Ktoris here, our General Manager. I'm Marc Intervera, our Research and Development Manager. Nick's going to do a little bit of an overview because we took the assumption that maybe not everyone really knows who Sentek is, what we do, and how we fit in. So what I'll do is I'll pass over to Nick first, who'll do a small presentation over Sentek, and then I'll discuss our findings.
Okay. Well, welcome everyone. Thanks, Michael, for the opportunity to present here today. For those of you that don't know me, my name's Nick Ktoris. I'm the Managing Director of Sentek, and my colleague Marc Intervera is the Manager of R&D and Training. So who is Sentek? Well, Sentek Technologies is an Australian-based company manufacturing world-leading sensors and solutions for precision measurement and management of soil water, soil temperature and salinity. So there's a picture of Australia. One would know Australia, but you can see that we're from South Australia, that little dot down the bottom there. The company was founded back in 1991. We say Sentek was established in the driest state, in the driest continent on Earth, with a vision to find a scientifically proven and commercially viable way of irrigating more efficiently and effectively. The company was backed by a local group of irrigators who recognised the importance of what was being developed and understood that they could not afford not to have the technology. And as I said, we're based in South Australia. Obviously, there's a picture of Adelaide if you haven't been there before. So we've been in business for 34 years. We were founded back in 1991, as I mentioned. We've sold in excess of 2 million sensors. We have a global footprint. We work in 6 of the 7 continents, haven't quite got the Arctic yet, exporting to over 80 countries around the world, 200 plus active dealers at any one point in time. We are ISO 9001 accredited. We obtained that back in 2013. This is a very important milestone for Sentek. It just reinforces the Sentek quality that we have. We bring in external auditors every year, and then we do a re-surveillance audit after 1 year. Every 3 years we get re-audited. So it's really important to us to have the independent verification of our quality and our brand. So just a couple of small things that you may not know, but water scarcity is one of the biggest issues facing the world. You can see there we have 55% growth in water demand by 2050. Our population is growing by 82 million annually, and our current population is sitting at 8.1 billion. It's expected to grow to 10 billion by 2050 and 11 billion by 2088. Now, when you think about that, that's massive growth in a short period of time. But the real kicker to it is that we're facing an unprecedented water issue globally, and that they expect that the scarcity of supply will be 40% by 2050. Now, 2050 is not that far away. So, as climate changes and the world population booms, agriculture will be forced to do more, produce more food, fibre, animal feed, and fuels with less water. And this is obviously where Sentek can help. Okay, so just explaining what markets that we're in. We have 4 what we call very distinct pillars. Agriculture is one, so we're talking about horticulture, viticulture, and other things there. But we're not only in that area, we also work in research, landscape, and environmental. We work with a group of partners which we're very proud of. You can see some of those are sponsors for the event as well, which I didn't realise until I saw that on the bottom of the guide. So yeah, we're very happy to work with open API collaboration with industry partners, and people can export the data from our IRIMAX Live program. So just a quick thing on our current products. So since inception, we've probably commercialised 20 odd products, including 10 complete product ranges, but there's hundreds of variants. I won't go through what's on the screen there in any great depth, other than to say that we have a full solution offering. So we think about getting the product in the ground, making sure that we don't disturb the soil structure, making sure that we do provide good quality data, so that when you're looking at your insights, with all your other technologies feeding data in, that you get really good information and you can make informed decisions. Not modelled, but real data, real information. And the last thing I'll just mention before I pass back over to Marc is that scientific credibility of the Sentek products is really important to us. So to have peer review, as I say, is very important to Sentek, and to have these organisations use our products indicates to us that we must have got something right. We have over 100 independently published scientific papers out there, so we're not a fly-by-nighter. We're here for the long term, and we're proud of what we've achieved. Thank you very much. Appreciate it. Marc, you want to come on up?
At Sentek, our commitment to innovation drives our sustainable growth and continuous development of cutting-edge products. Our dedicated multicultural team of over 50 talented professionals is the cornerstone of our success, enabling Sentek to maintain its position as the global leader in soil moisture content technologies.
We are a globally recognized leader in designing, developing, manufacturing, and distributing world-class technologies for measuring and managing soil moisture, salinity, and temperature. Our expertise spans diverse fields, including research, landscaping, environmental management, underscoring our commitment to excellence and sustainability.
With over 2 million sensors sold in over 80 countries, we collaborate with a network of over 300 dealers addressing diverse climates, crops, and environmental projects worldwide.
Sentek was founded back in 1991 in the dry state, the driest continent on Earth, right here in South Australia. Sentek's vision was to be globally recognised as best-in-class provider of soil, water, and solute measurement and analysis for decision support. We are well on our way of recognising and reaching this goal.
Our growers who use Sentek technologies save on input costs, reduce waste, increase crop yield and quality, and ensure long-term sustainability. Supported by a global network of highly trained dealers, our representatives are based in the United States, Canada, Australia, New Zealand, Europe, Africa, Asia, South America, and the Middle East. And we work closely with the innovation of pioneers in the industry, including universities and institutes.
Our significant growth over the past few months is due to the hard work, dedication, and passion from each and every member from the Sentek team. We are not just a large business, but we also provide a sense of belonging to all the members of the Sentek team.
I'd just like to take this opportunity to thank all our stakeholders, our shareholders, our employees, our dealers, and our partners and suppliers. Thank you.
Basically, I'm just going to run over a bit of the experiences we had with the Tasmanian University and the Soil CRC. As we see, there was a memorandum established in July. We had the integration of the Bilby with the Sentek ecosystem, which meant we could actually integrate the data that came out and bring it back to our IRIMAX Live platform. Like Marcus mentioned, Sentek's one of them companies, we actually like to get dirty. That's what we do, we work with soil. So Mike Portman and myself, who's our senior engineer, went out to Trumbridge. We actually installed the site. We had a look at the university, spent a few days there to understand the logistics of what was happening. Then over time, it developed and it evolved, and we had many discussions about commercialising this product and what we would see. And then we went through a couple more trials, which I'll touch base with. the right way? No. The big green button? Nope. Always happens. I commented how great your technology was, and I've gone and wrecked it. No, too far back. I'm wasting my time. Yeah, I'm not sure. Tech support here. The green one. Okay, I think we got it. Okay, so at the Trumbridge site, we actually developed, hold on, we'll go back a page. Yeah, so what we did was at the site, we had 2 installations that were located, and what we identified, well, actually what the Tasmanian team identified was that they looked at 5 and 30 centimetres below surface, and it initially for a grazing application. So what we found at Sentek, the grazing industry is probably not one of our highest sellers, but the technology is really important and really good, particularly of all the points Marcus made, which I won't go back into, but people breaking our stuff is one of the number one ways of our technology breaking or not working in the field, and it's generally by machines. What we had there was we had a heap of different gateways over quite a large area. And when we identified some of the variations in data loss, we installed a new gateway 150 metres to ensure we had a steady, constant signal going. So here at the gateway, it was quite a large, big gateway, but it was doing a lot of large, like a large area across the fields there. Part of the installation with the bilby, we did all the experiment out there on the field. We were measuring the depths to ensure that everything was precise so we could then replicate it in other sites. One of the things which we found as part of the protocol from the Tasmanian University was to use the Bunnings sand. Now, one of the things I brought up straight away was, what about biosecurity issues, right? It's a big thing across a lot of farms. And me as a farmer, I might not really be interested in buying some foreign soil and bringing it on my site, particularly when I don't know where it's come from. So what we've done, we moved the trial to a more commercial location, which was in Langhorne Creek. Now, this is about an hour and 20 minutes on the southern part of, Lake Alexandrina, which is fed by the Murray. So basically, it's one of the last spots you can irrigate before it goes into the Coorong from the Murray River. Generally good water supply, but it does cop a lot of the, waste and salt levels that come from all the way from Albury all the way down through the Murray. But anyway, so here at this site, we evaluated the site. We've got some EM38 data, and again, we set up the trial in the field using the 150 metre distance, 5 and 30 centimetres between the depth of installation. Now, we collected data over two entire Brussels sprout growing seasons. So for those that aren't horticultural among us, Brussels sprouts are like a 7 or 8 month crop. It's quite big. At full harvest, it's nearly as tall as I am. And we've identified through our trial work that Brussels sprouts is one of the hardest crops to get any sort of signal through. So we use it, and we've got a good association with some local farmers in that area that have been using our Sentek technology for 10 or 12 years. So we do a lot of trials, and we actually joke that this site was one of the most monitored Brussels sprout crops in the world, because I think at one stage we had about 25 different probes out there checking stuff. So quite interesting, got a lot of good data. The other thing what we did was, with the units being installed at the 30 centimetre level, we actually installed it in the middle between the 2 rows of Brussels sprouts. And what we're able to do is cultivate over the top. So one of the questions about being able to plant a sensor and the telemetry below the surface was answered. So we could actually do it and cultivate over the top. So if we had management systems like we get in vegetable production systems where we're doing more cultivating, we're actually able to have technology that's below the ground and not getting disturbed by the cultivation. This is just to give you a bit of an idea about what the site looked like. The image on the left with the round circle, that's where the bilby was planted into the field. And as you sort of see along, we actually see how the crop's growing. The third picture from the right where we see under the pivot, this was at the stage where the leaves just started touching together, where I'm going to show you some data that this is where we had problems. Marcus raised it earlier with the irrigation causing an issue to the telemetry, because this is really what we're looking at, sending that signal out of the ground back to the cloud or to a base station. Okay, so here at this site here, we established a base station 150 metres from the probes. And as you can see, the base stations weren't quite high. So this was our first test of them. So they were only around 1.5 metres, 2 metres around my height. Then what we did was we started evaluating the data. Do I have a pointer on this? Which button is it? The top? That one. Oh, perfect. Okay, so what we did was here, we had data coming from the 5 centimetre below ground and 30 centimetre below ground. Now we started seeing, when I showed you those photos where the leaves touched, we started seeing drops of data. Packets of data weren't getting delivered. We actually thought maybe there's something wrong with the bilby. So what we did here, we actually used the 5 centimetre bilby that, as you can see, was getting us really good data. And then here at this spot, we actually changed it. We pulled it out of the ground, the bilby, and dug it 30 centimetres under the ground. This was more just to truth check that there wasn't any problems with the bilby. But what we identified, if we sort of see here, there's all a loss of data. So this was at 5 centimetres and this was at 30. So again, we're having the problem with data loss. This is just same image, just a little bit closer view, so you can sort of see how much data was lost. If you sort of see where that green and yellow line meet, that's what we were expecting. That was the required amount of data that should be going through, and what we're showing you there is what actually happened. A quick overview, because I reckon I'm running out of time. This is the 5 centimetre above and the 30 below, and we can see how there's such a huge variation. Now that variation came from the bilby being able to send telemetry through the soil, through the crop, back to the base station. So this is where we went back to the Soil CRC and the University of Tasmania, had discussions around what we were looking at. Marcus alluded to it at the end of his presentation, where they spent a lot of time developing and looking at new aerial technologies. So what we ended up doing was, for the second site, we ended up getting a new version bilby, not as flash looking as the original prototypes, and Marcus does have a nice prototype looking case downstairs for you all to see. But basically we moved to the new site. The site was a little bit heavier and not much heavier, but it's still a little bit heavier than the other site, and generally these are sandy loam soils. We installed 2 gateways at 2 different heights to start understanding whether the height of the gateway had an effect on what was happening. And then we also had 4 of the new aerial units. We installed them for about 2 months, and I'll talk about some of the issues relating to projects when with this example where the Soil CRC is working with us to commercialise a product. There was a few issues there, but we got the probes in the ground, or the bilbies in the ground, and we actually also, which I'm not going to present the data, but we even identified the location or the angle of the aerial in relation to the gateway had an effect on how much data went through. But I'm not going to present that data, but we do have that data available. Okay, so here we increased the heights of the bilby. We also added leaf sensors and a weather station, because part of the trying to understand what was happening is we all wanted to understand what was going on not only in the bilby, in the soil, but in the crop. How much was that soil or the moisture in the Brussels sprout, in this example, affecting how the data was being moved across? The other thing I will point out, at all these sites, we actually used native soil. We used the soil that came out of the site. The initial discussion when we changed the protocol a little bit was that around the biosecurity issue, and also the sites we were testing were generally a sand to a sandy loam, so very similar to the types of soil that were predicted to be or suggested to be used above the bilby. And the other comment I had is no farmer's going to go to Bunnings and buy a bag of sand put on his bilby. So we have to be adaptable in that the farmer's going to use what's there. So we need to test with what's there. This is a bit of a look at the new bilby and what it looked like and how it went in. Again, we used the same protocol of 30 centimetres below ground and 5 centimetres below ground. This is to give you a bit of an idea for those who haven't played in a Brussels sprout crop. It's thick, it's dense. I mean, this was when we installed the bilbies, the crop was already quite high. Well, this is the second part with the new aerial. So yeah, just to give you an idea, it's a thick canopy, it's a dense structure. And let me tell you, when we pulled the probes out prior to harvest, we haven't got those photos, but let me tell you, it was a fun day. You get wet no matter how dry the weather is because they hold so much moisture, those leaves. Here's a little bit of a look at the soil moisture, the leaf moisture sensors we installed, and seeing how they were relating to the soil or to the irrigation moisture and the density of the crop. And these were again above, in the middle and below the crop, so we had a good representation. Now, this is the data for the new aerial. So what we see here is, again, where the green and the yellow lines meet, that's where we want that's the ideal number of points. So here, what we did was we had the testing going on. I'm not sure, we're going to call it a bilby data loss here, which was the only little glitch we got for the whole experiment of the new aerials. At this point here, we actually, and sorry for the ones on this side because you can't see my point, so this was the bilby glitch, and at this point here, where we see the green change to the yellow colour, we actually did a remote program change. So we actually increased the amount of times that the bilby would sample. So we doubled it. And what we actually identified was that we can actually send data remotely to the bilby. It can understand the data we've given it, make the associated changes, and as we see, give us the results. That's why these graphs show an increase in the amount of data that was received, because at this point here, we actually gave it the command. Well, the guys from Tasmanian University, Daniel, I think it was, wasn't it, who's ran that part of it? He gave the command, and working in with our senior engineer, Mike Portman, created it, made it happen. And I won't lie, that's the realm of where I don't really understand. My background's production, horticulture and agronomy. So, but from my point, it worked, and that's really was a big success. So that's what we really found was really good with this project. And now what I'll do is I'll just talk about the project and where we got to. So what we've done is we've summed up between what Marc has showed you and what I've shown you to get to the point. And I think it's been about 2 years, Marcus. I think it is September 23 from memory. I think we did the first catch-ups and site visits. So around 2 years we've been involved with the bilby. And still what we found was the collaboration between the university and the technology that they've developed, us as a commercial partner who can actually expand the manufacturing and the distribution network. As Nick showed earlier, we've got a large distribution network globally. But I suppose what there was a few shortfallings in like having the project ready. So, and I'll jump between this and the next slide, but I suppose one of the big outcomes that I've noticed is that with any of these projects, you really want to touch base with people like Sentek, not just Sentek, but any industry partner in month 6. I think Marcus and I were talking about it. They were running the Bilby project for almost 3 or 4 years before we were contacted. So there's a lot of learning, and I suppose this is one of the things for the CRCs to really identify industry partners and identify not only methods to market, but what does the end user really want? So, you know, and your experience was definitely correct. The end user wanted a probe that wouldn't be broken underground, but then we have other constraints, and I suppose where Sentek came in, we've already identified that. And sorry for all the dryland farmers in here, but it's not a big area for market expansion. It's not somewhere where we see lots of growth in the industry. But let's say we put the bilby in a crop of almonds or possibly grapes or citrus or macadamia nuts. Okay, now we've changed the ball game because they're high-value crops. They're crops that have a lot of machinery going underneath them, particularly almonds and macadamia nuts. They'll get in there and shake them. So we don't want that technology sitting out of the ground like we used to. So this is where I think the collaboration with projects, the industry partners, make it happen earlier. Don't wait till year 3, because a lot of these insights that we've got here that we still need to, and I won't go through them all, but this is basically what's left to do to commercialise the product. So we went from the original bilby, then we ended up testing this one, and this is the one prototype downstairs which you guys can have a look at. So I'll just jump to my next slide. Final thoughts on the whole process. It was great. We got what we wanted. We had an aerial that would send data from 30 centimetres below ground to a gateway that was 150 metres away and successfully integrated into our platform, Iramax Live. The big one was the open discussion of ideas, the requirements of what we needed, and this is the point where I made by touching base with industry bodies earlier, or the potential partners. Some of the stuff on the previous slide we actually possibly could have done if we started a bit earlier on it. Look, and we're not having a real whinge on this one, but you know, with the restraints, we got close to getting this project done, but then the university and the different bureaucracies there slowed up the project. We couldn't get resources when we wanted. When they came, they were a bit late, but we dealt with it anyway. And I suppose for us, we've got this project to a really, from my end, really exciting point, and the funding's finished. Not saying that we're not going to run ahead with this and drive it ourselves, but it would have been good to have a little bit more time to finish off, particularly, does that work? Particularly to get on top of some of these. And but outside of that, it's been a really good process. We've actually had some solid outcomes with that, developing the aerial. So it's definitely been something that's been really beneficial for Sentek. At the moment, we're in the process of evaluating how this will fit into our product line, dealing with our parent company around that. But yeah, look, definitely excited. Really appreciate being here. And the other thing I'll just say to you all, if there's projects that you've got out there, talk to the industry partners as early as possible. Even now, because I see some of the projects you're working on, I could see how there might be some areas where we can maybe assist. If you've got some ideas, feel free to catch up with me in the breaks. I'll be here for the rest of the day and tonight. Unfortunately, I've got to jump on a plane tomorrow morning. But I'll be around for the rest of the day and tomorrow. So definitely open to talking to people about ideas and even just things that you think might be of benefit. I really like that mapping data I saw earlier. That's really cool that you presented. That was amazing. And I really see the benefit of that. And look, my goal would be to have some soil data similar to what the USDA have presented. And I know it's bigger country, more funds and all that. But really, to me, that would be a really good tool for all farmers in Australia to have a better overall soil map. Any questions? I'm happy I think I've got time, or how's this work? I'm over time.
Just Just wondering, we've got a couple minutes, just whether there's some question you would like to ask either Nick, Marcus or Mark. All answered.
You just mentioned, it might have been an off-the-cuff statement about dryland agriculture not probably having a suitable fit for these Sentek moisture probes, but the next dimension I feel in dryland agriculture in Western Australia in particular is actually leveraging moisture data for better nitrogen decisions. So that when you scale it up for large broadacre businesses, having one moisture probe is not enough. You might have 10 over 5 to 10,000 hectares, so it is a scalable product. And I think a lot of metrics, like you mentioned there very at the end, about having soil data and soil maps, choosing the right locations that are inherent in good decision making, I think that's actually a very valuable business proposition.
So yeah, to comment on the dryland, I'm just sort of commenting on what we've done and what we found from a dryland point of view. Unless you guys have got a drought, you don't even talk to us. It's really funny when we've got drought conditions in the country and we're doing a workshop or something, we get all the broadacre guys wanting to understand more about soil moisture, but then you'll get 40 mils of rain and it just goes off. It's just one of those interesting things. I understand that a lot of dryland farmers want to understand more about the soil moisture, and look, I'm just making the comment from where I sit. What we found is that generally the broadacre farmer isn't as keen to adapt our technology because he thinks, well, I can't add any water, so how does it benefit me? And I know that's possibly part of our issue or something we need to identify because we haven't educated that farmer well, but it's certainly something we're looking into, and it's certainly something we do, particularly looking at soil moistures coming into, making decisions, and particularly more around Victoria, this has been more prevalent, but where they're putting in a probe in a dryland situation to make those decisions. Am I going to finish this crop for grain or am I going to cut for hay based on my soil moisture? But look, we're definitely interested in doing more. It was just more an observation of what we see the industry doing right now.
All right. If there's no other questions, I'll just hand over to Michael.